Welcome back, geometry students. Today we're going to be talking about section 10.5, which is trigonometry and area. So if we have a triangle and we're given three measurements, SAS, how can we find the area of ABC? Now, why is SAS important? Well, you're not going to be always given the needed information in a triangle. As we recall, the area of a triangle is 1/2 times the base times the height. But what if we're not given the height and we're only given some of the periphery parts of the triangle? Okay, so for example, let's say we're given, let me change this to yellow. Let's say we're given C, let's say we're given B, and then we're given angle A. So we're only given two side lengths and then the angle in between. So that's SAS right here. That's where that comes from. How can we find the area since we're not given the needed height? Well, using trigonometry, it makes it a lot more simple for us. So if we're given this angle, angle A, then we know that the sine of A, and we use capital letters for angles and lowercase letters for side lengths, is the same thing as the height, which I'm going to label H, over the hypotenuse, which is C, okay? Because as we remember, sine of an angle is equal to the opposite over the hypotenuse. That's just a trigonometry refresher for you. So we know that H is our opposite side in relation to A if we make it into a right triangle, which it is. And we know that C is our hypotenuse because that's its longest side opposite the 90-degree angle, okay? So how could I express sine of A, or excuse me, how could I express H in terms of the other two pieces of information? Well, I need to solve for H. So I would multiply both sides by C. So then I would have H by itself. H would equal C. I'll just leave it in red. C times sine of A. And that is my height. This whole chunk is my height. Now I'm ready, if I'm given B, okay, there's my B. Now I have my H, there's my H. I have everything I need for the area. So let me move this green actually out of the way. So now that I know these two pieces of information, I'm ready to write my equation, which I'll use pink. They'll stand out. So that's 1/2 my base, which I'm given in this case, side angle side, times, I'm just going to write this instead of H. C times sine of A. So 1/2 BC sine of A. And usually you'll see it written like this, just so you know that you're not going to be doing anything funky. You're going to take the sine of A, then multiply that by B and C, and multiply by 1/2 or divide by 2. So there we have a very useful formula to help us with any sort of problem when we're not given the height, but we're given a side, another side, and an angle in between. So we're going to go ahead and apply this now. So we have the first example with a triangle with 21, 12, and 48. The angle 48 in between the two sides. So we can go ahead and set this problem up. So make sure you have a calculator ready because you're going to need to take the sine, cosine, tangent. Well, in this case, just the sine. So let's go ahead and set this up. So area equals 1/2 BC times sine of A. Now, labeling is going to be very important in this. So I'm going to use blue to label. And make sure you use lowercase for side lengths. So I'm going to call this B and call this C. Now, does it matter which one you call B and C? It really doesn't, since you're multiplying the two. And it's not affected by order, so you can call either one B or C. But this one has to be A. So the angle in between has to be your A. So I'm going to do 1/2 times 12 times 21 times the sine of 48. Also make sure you're in degree mode. If it says degree, Okay, in geometry, we're generally in degree mode for most of the time. In pre-calc, you're probably going to be in radians most of the time. Okay, so sine 48 times, and I can just see already that I'm in degree because I got a negative answer. When I typed in sine of 48, I got negative 0.768. Anytime you get a negative with degrees, you're definitely in radian mode. So I need to change that to degree mode, sine 48. And this time I got 0.743, which makes a little bit more sense. Now I keep it saved on my calculator. It's actually about 9 digits long, but I'm just writing it here a little shortened for simplicity's sake for you guys to see. But I keep it kind of saved on my calculator, and then I'm going to multiply it exactly how I see it. So I'm going to multiply this by 21 times 12, and then I'm going to divide by 2 at the end, and my answer, area, equals 93.63. I'll leave it like that, units squared. Don't forget the square units. And it's as simple as that. Okay, so there's our first example. Now moving on to, well, that one was, I guess, example 0. This is example 1. And it looks like we have another example 1 coming up after this. We'll change this to 2 real quick. Example 2. There we go. Oh, forgot the color in the sun. That's very important. Got to get that energy from the sun. Okay, so now we have this new triangle, and it asks to find the area also. Notice how we don't have a height. We're missing a height. Okay, so we're going to have to use some trigonometry here. Now here's the problem. We're given a side, we're given another side, and notice how we don't have the angle in between. So what do? Well, if we have 2 of the angles, we can easily find the third. So we're just going to do 180 minus 107, and then minus 23. And that will tell us our missing angle, because we know the sum of all 3 angles need to add up to 180. And I get 50 degrees. Now let's label. So I'm going to make 8B, 10C. I'm going to make 50 is going to be my A angle. Capital A for angles, lowercase letters for sides. And I just plug it all in. So we have area equals 1/2, B, which is 8, C, which is 10, and then sine 50 degrees. So the sine of 50, I'm going to start with that. That way I can kind of keep it saved. And then I multiply that by 10. I multiply that by 8. And then I divide by 2. And I get 30.64 units squared. So you can see using triangles with side angle side is pretty easy. It's kind of like a plug and play. You might have a little bit of work in terms of finding the missing angle. You might have to use some intuition. There might be some 30, 60, 90 triangles that you need to solve before getting the last angle. But in general, it's pretty straightforward for finding the area.